So what is understood from the load diversity factor is that the diversity should be as high as possible. So I can have one more thing. If whatever we saw in the previous graph was like this. So rather than having a single peak in the maximum one, I can have a peak like this. If the area of both the triangles are same, suppose, or like this, or I can have a graph like this also for my load factor. So since the graph is going up and is almost a constant right now, so the diversity factor will be higher and the installed capacity of the system will be coming down. And as the installed capacity is coming down and as the diversity factor is going up, at that time what will happen? The cost of installation of my total system will come down and I'll be able to produce my electricity as economical as possible. And if I'm able to increase the diversity factor, if I'm able to increase the plant capacity factor at that time, the energy which is coming out of the generator or which is coming out of the synchronous alternator will be of a very low cost, and that if it is of low cost, it will be economical for the consumer to use it. So the diversity factor and the plant capacity factor should be as high as possible. So now coming to the plant capacity factor. What exactly is the plant capacity factor? What is plant capacity factor? It is the average demand divided by the rated system capacity. So plant capacity factor should be as high as possible. We can see that if the average demand is high, at that time the plant capacity factor increases. If the rated system capacity increases but the average demand is low, at that time the plant capacity factor will be low. So I'm not using the full capacity of my plant. So if I am designing a plant of 100 megawatt and I'm using it for 30-40 megawatt only, so I'm wasting the 60 megawatt which that could have been produced. But since it is not required to produce 60 megawatt, so I have wasted that 60 megawatt and the plant capacity factor at that time will be lesser. And since the plant capacity factor will be lesser, and one more thing will be there, that the system which is right now working on 30-40 megawatts will be producing electricity of higher cost, and that would be actually leveled to the end customer. So I should be having as high as possible the plant capacity factor can be. So one more thing which is called a plant utilization factor. Another thing which is called the plant utilization factor is actually the maximum demand divided by the rated system capacity. It's called the ratio of maximum demand to the rated system capacity. One can clearly see from the plant utilization factor, that is called the PUF, plant utilization factor, that if the maximum demand is equal to the rated system capacity, the plant utilization factor will be 100% or 1 at a time, and that is an ideal system which we can reduce. So for that, I should be having a load curve somewhat like this. If the total installed capacity is equals to the maximum demand of the system, and suppose this is my maximum demand and this is also as my rated system capacity. So at that time the plant utilization factor will be 1. And since this is also average demand, so at that time the plant capacity factor would be as high as possible. So it's also equal to the plant capacity factor. The plant utilization factor and plant capacity factor would be equal if the average demand and the maximum demand coincides. That is very much rare. That is not practically possible in a system. But theoretically it is possible to have a plant capacity factor is equals to plant utilization factor only and only when the average demand and the maximum demand coincides, or the average demand and the maximum demand are same. So these two formulas are very much important regarding objective type of questions. One is called the plant capacity factor, which is equals to the average demand to the rated system capacity. Another is called the plant utilization factor, which is equals to the maximum demand divided by the total system capacity or the rated system capacity. So these two should be as high as possible. So plant capacity factor and plant utilization factor should be as high as possible. One more thing which counts here is called the loss factor. What is called as a loss factor? Loss factor is called as the ratio of average power loss to the power loss at peak load. So normally we are having losses anytime, at the starting of the day also, at the maximum time also, at the when the load is minimum. Every time we are having losses, as we have seen in the case of transformer, that in the distribution transformers we have losses, iron losses all the time. So copper losses increase or decrease according to the load, but we have 24 hours losses. So the loss factor also increases or decreases according to the load. So we have average power loss, which is actually the loss which is in the average form, and the power loss at the peak load. So if the peak load power loss increases, the loss factor decreases, and if the average power loss is increasing, the loss factor also increases, and which is not desirable. Loss factor should be as low as possible. So the power loss as peak load should increase rather than the average power loss. So this is almost all the formulas for the load characteristics, and we have discussed almost all the load characteristics.